So now we're going to talk about a new kind of a data structure called a linked list. And so we're going to start by reviewing what an array is. So an array is also a data structure that you can create to hold data. It's a structure that holds data, or a data structure. And so when I create this array called num and I assign it these 4 values, I'm going to print out the address of each of the cells. So when I run this program, you can see that this is the address of where num begins. And then if you notice, each address goes up by 4 bytes because it takes 4 bytes to store an integer. So if I were to draw this out, what it looked like in memory, I have my 4 cells, index 0, 1, 2, and 3. And then I'm going to assign them the values 3, 5, -8, and 2. And where this array is stored in memory is at the address of num. So wherever num sub 0 is, which we can see it's right here, I can easily calculate the address of num sub 1 by just adding one integer, the size of one integer, to wherever num starts. So since this is where num starts, if I add the size of one integer, I get to cell 1, and that's the address right there. So keep that in mind when we start talking about a linked list. How a linked list works is it's kind of like an array. It is a list of elements, but unlike an array, it can grow and shrink because we are going to be using dynamic memory to allocate each element of our list. And so how it will start out is you'll have a variable, a pointer variable, that's going to hold the address of the first element in the list. So you'll go out into memory and you're going to create what's called a node. So you're going to allocate space for a node. And in this node will be room for an integer to hold the data, and then room for a pointer to point to the next node or the next element in the list. When I first start, I have a pointer variable, and we're going to call this pointer variable head, and it won't be pointing to anything. But when I'm ready to add the number 3 to my list, I'm going to go out into memory, create a node which will have a variable to hold the number 3, and then a pointer that will point to the next element in the list. And so when we create our first element, it will be pointing to null because it's the first element in the list and then the last element in the list. And then head will be pointing to wherever that node is. So then when we're ready to add our second integer, we're going to go out into memory and create another node and assign it the value 5, and this node will be pointing to null because it will now be the new end of the list, and then the address of this new node will be placed into this location right here. So now the first element in the list, its pointer to the next element in the list will be updated to point to the new end of the list, and this will no longer be null. So that's kind of how the linked list is going to work. Unlike an array where we can easily calculate where the next cell begins, we're going to have to keep track of where the next cell is, because when we create these nodes in dynamic memory, they're going to be all over the place. They're not going to be right next to each other. So that's why we're going to have to create it this way.